So now that we know how to use our roadmap, let's go ahead and do an example problem. How many grams of copper are produced when 37.8 grams of solid copper 2 oxide are decomposed? And so this is going to be really easy to do. The first thing we need to do is write our balanced equation. And so this is where your last couple units of predicting reactions is going to come in handy. So I have copper oxide, which it says is solid, decomposes, that means it's going to break down. It tells me that copper is going to be one of my products. And so that will be a solid. But since it's binary, there are 2 elements only. And so that means that oxygen gas will be my other component. Remember that oxygen is a diatomic, and so it needs to be O2. It never exists as a single atom alone. And so there we go. There's our equation. Let's go ahead and balance it real quick. And so I have 2 oxygens in my products. I need 2 oxygen in my reactant. Now that I have 2 copper on my reactant, I need 2 copper on my product. And so there's my balanced equation. We're going to use our roadmap. And so when we look at our roadmap, it tells me that my starting point, my given, is going to be 37.8 grams of copper 2 oxide. And I'm trying to get to grams of copper. So I'm basically going from grams of A to grams of B. So this is my first starting point. Along this way, this is my finishing starting point. This is my finishing point. And so as I go through, I go from grams to moles. I'm going to take the easiest route there. So then moles to moles, and then moles to grams. And so it tells me I'm going to have 4 stops on my roadmap. So when I write my roadmap down here, I'm going to go from grams of copper oxide to moles of copper oxide to moles of copper, and finally grams of copper. Now you'll notice I also wrote down my molar masses, my molecular weight in grams off to the left there. I like to have everything right where I need it so I don't have to keep going back to my periodic table. You don't have to write that stuff down, but if you're somebody that likes to have everything ready for when you do the math, then go ahead and do that. So then now I need to write my ratios, and with my ratios I have grams of copper oxide, remember that on my roadmap that I just wrote up above, everything that's there is the top of the ratios. So since I have 4 stops, since I have the 4 parts there, it means I'm going to have 4 ratios, and each of those is the top of each ratio. So you don't have to do that top step. You can just write it as this step instead of the arrows. You do your multiplication sign. So then remember, what was on top goes on bottom. So the top of my first ratio becomes the bottom of my second. The top of my second ratio becomes the bottom of my third. The top of my third becomes the bottom of my fourth. And now we just need to plug in numbers. And so remember that this is going to go over 1. The given always goes over 1. And so now I have 37.8 grams of copper oxide. When I go from grams to moles, maybe I forget how to go from grams to moles, but if you remember your roadmap, it makes it very easy because I can see to go from grams to moles, to go from stop 1 to stop 2, I need to use my molar mass. And so coming back down here, the molar mass of copper oxide is 79.55 grams in 1 mole. Again, looking up here, I'm going to shrink this a little bit so I don't have to keep zooming back and forth. Don't want to make you seasick. When I come back up here, I look and I see that now I'm going from ratio 2 to ratio 3, so moles of A to moles of B, and I'm going to use mole ratio, which is the coefficients of the balanced equation. And so coming down here, I need 2 moles of copper produced for every 2 moles of copper oxide used. And then finally, to go from ratio 3 to ratio 4, I need to use my molar mass. In this case, it's the molar mass of B because it's moles of B to grams of B. And so the molar mass of copper is 63.55 over 1. Then you just plug it into your calculator and that's all there is to it. Go ahead and pause the video here and calculate it and see if you get the correct answer. The answer that I got was 30.19 grams of copper produced.